Last week, the stuff on screen, we jumped around a little bit between parts and drawings, and one of the things we touched on was configurations. And configurations will allow you to do some things in drawings and the parts to maintain your existing assembly and parts the way we had them in Project 1, but also have another version, which is the one you'll be modifying in Project 2. So I'm just going to go over that again quickly, because I'll get everyone to play around with the configuration just for this form bracket, so everyone knows how to do it. And I'll also show you how to fix mate errors, which we've got here now that we can turn this part into sheet metal. All right, so first thing, I'll just go back to the part. Now I've got some errors in my assembly. I'll come back to them at the moment, but you can see they're all in the mates folder. What those errors are all to do with is when I turned this part, the form bracket, to sheet metal using that convert to sheet metal feature, even though it's the same shape, it's just changed the references of all the surfaces and holes. Okay, so in my assembly now, where it's looking for this concentric mate, if I click edit feature, okay, you can see here there's a missing face, missing reference. To replace that mate, all I've got to do is click on that missing face position there, and then just reselect the missing face, press OK, and that'll update that mate. Now sometimes some of the mates, like the one here, this coincident mate on the side, sometimes there's multiple mates to the same surface, in which case you only have to update one of them and SolidWorks will pick up all the other mates that are missing that reference and it'll update it for you. I don't know if we've got many in this instance, but it's not too hard to go through and fix those up. The other way you can do or see where those mate errors are is to actually click on a part. Okay, so part 3, click on this button here, View Mates, which is the paperclip with the eye. Okay, and that's going to show you all the mates, and it's going to isolate those parts, so it's a bit easier to see on your screen. And then you can see the error here, coincident. Click Edit, and then you can replace that mate with the missing reference. So this is the example here. There are other mates with the same missing reference. Would you like to replace the other missing references with the one listed? Yes. And now all my mates have been fixed, which is good. All right, so just to show the configurations again, start with your sub-assembly file and click on this configuration manager and just make sure you've got a second configuration here. So you right click on the name of the part and go add configuration, and then you type in the name of it and that will add one. So we've added a prototype configuration here. Right, and it's in this prototype version where I've suppressed the washer, and later on I'll show you a different version of the pivot pin that'll be in here, but we'll also add in the different version of the form bracket. So now I can open the form bracket and do the same thing. So you can see I've already got them here, but to add that configuration, right click, add configuration, type in the name. To activate it, well, it will activate automatically once you create it, right? But to activate it, if you've changed out, just double click. And so the difference between our two parts here is a few dimensions, okay? And they both have a convert solid feature because our existing part, which we've turned into sheet metal so that we can flatten it, that's at 3mm thickness. Whereas our new part, in the prototype configuration, is at, I think maybe 2mm. So to convert them, here we needed two separate features because with the convert solid, you can't separate those into different configurations. So I'm just going to save as a copy and open just to show people how to do that from scratch again. Alright, so this is my copy file. I'm just going to delete these configurations and features. So it's my default. Alright, so let's delete that. So first up, add configuration. Give it a name. Then the configuration, edit the sketch. And double click on the actual dimension that you're going to change and make sure it's linked to this configuration. Once it's linked, you can change the dimension. Now the dimension for this part is going to be 21. So I change that to 21. I'm also changing some of the other dimensions here. My thickness to 2, my outside radius to 3, then I'm going to edit. Now I'm not going to edit these ones, I'm actually just going to suppress. So I'm going to suppress that cut extrude 1, cut extrude 2. Just bump that size up to 10.5. Now that's fine for both versions, so that's why I didn't link it to a configuration. On this side, I'll now do the hole. Now this hole is going to be for the bolt, so I don't need to make it 13 plus because there's no bush going through, it's just the bolt. I think the height off the bottom is to be 8, so we can then cut all the way through, and then to finish this part off we'll do some fillets. It's 5mm on each of those corners. So there's our configuration. So if we go back, we can see we've got the original, and then the new version, and now we can convert to sheet metal. So this is where convert to, this version is going to be 2mm thick, internal radius of 1mm, collect bends, okay. When we go back to the default configuration, we do the same convert again because we need to convert this to sheet metal as well, but this one's 3mm. Collect all bends, okay. That one can change to sheet metal as well. Is there anything in that series that anyone doesn't understand? I've gone through it quickly because we've already done it once last week. It's on the video already. All right, and you'll be able to have a look again later on. So once you've done that configuration there, now I'll just close that part because I've already done it once here. To show it in this assembly, I'm on my prototype configuration. I click on the part, click on the drop down, and I make sure it's linked to this configuration, and I can change the version to the prototype version. Now that might cause some mate errors. That's okay. With these mates, instead of deleting them or editing them, you can suppress them. Okay, so suppress just turns them off, and instead you can add new mates. So if I need to add one to make it concentric, I can add a new one there, and a new one to make it coincident. So one of the good things about configurations is the ability to use them in your drawings. For this project, you don't have to do this. This is just showing you one of the tools of configurations. I can create a model view of my sub-assembly. If I want, I can have all three views, standard views, whatever, exploded views even. You can also then have a comparison between the two configurations. So to change the configuration of this drawing view, I select the view, and under reference configuration, at the top, I can hit that drop down and select prototype, and it will show the different version of that. Now, notice this one here, there's no exploded view there, okay, because I haven't added one. But if I go back to that assembly and see this exploded view here, I can actually, if I'm back on the default configuration, I can select the exploded view and hold control. Let me just try and get this working. Actually, just drag it. I can just drag it, copy that to the prototype configuration there. All right. What that does is copies that exploded view. All right, so back in my drawing now, I can select that drawing and click show exploded view, and it'll show the same one. All right, so you don't even have to repeat the steps, it's already there. As long as it's the same parts, it'll be there. The other thing you can do is alternate position view, where you can have overlaying views under one drawing. So I can select this front view here, select alternate position, and I can select existing configuration prototype, and it will show the two versions, one overlaid over the other. Not necessarily useful here, but there are situations where that could be very useful to show those different versions. And you can have multiple, so you could have 2, 3, 4 versions on the one drawing showing different alignments, different configurations. Okay. All right, so there's not going to be too much more on the drawings done today unless we have a bit of time at the end of class. What our focus is today is on trying to get our prototype parts done. So today we signed the groups last week. Anyone that wasn't here, I'll tell you whose group you're in a second. And in earlier weeks I showed you some of these pulley prototypes. I brought a couple of copies in again for you guys to have a look at. Okay. The ones with the metal wheels and the clear sides are the newer versions which we're doing. These ones here, which are a bit rougher, this is what we used to do. Okay, we used to do just CNC foam for the wheels, and the sides were all done from metal. And as well as the pivot pin, we used what was called a DI wire bender, which is a CNC controlled wire bender, just not very successful. Yeah, so now we're able to do the pivot pin on the lathe, here Sam. able to do the pivot pin on the lathe, it's a much better result. But you just get an idea of sort of from this, the customization that you can do these parts, all right? And we're not doing anything, you know, groundbreaking. It's just seeing how you can make a few minor changes and edit them and go through the process of then exporting that file ready for sending to a workshop. Okay, so we'll go through those steps over the next hour and a bit. So the way we'll do it is on screen, I'll go through the modification steps for that part and how to export that part. Once we're through all of the parts, I'll then show you how we import them into an AutoCAD to fix up the line work, all right, and how they're nested. Okay, so you get an understanding of that process as well. So while I'm not doing the part that you're working on, you can continue working on your drawings, or you can follow along and just have a go anyway. It's up to you. But the only part that you need to send to me is the one that you're assigned for your group. Okay, and what I'll be doing is I'll have up my email here. Okay, and you'll just see on the side of the screen, you know, once you've sent your email through, it'll come up here just to make sure. All right, so it's a sort of an accessible part for everyone that you've exported and submitted a file. Okay, we'll go through that process later though. So parts, then you need to pay attention to this next steps.
Chris?
Yep.
I just have one question. Back in the sub-assembly,
Yep.
You right-clicked on the part 4 and changed the version. I just
Yep.
missed that part. It seems important.
So in the configurations, so if we're looking at the prototype configuration and we want to see what the prototype part looks like, click on the part and you should see this drop down. Okay, and then you can click on the prototype configuration, press the tick, and it will change it to that version. Okay.
Cool. All right.
How did you copy the exploded view again into different
Yep.
configurations?
So in the configurations,
Yep.
you can only copy it from the current configuration. So you have to be on the default one.
Yep.
Then you just select the exploded view and drag it. And once it drags, you see that little arrow, and it's basically like an arrow plus sign.
Yep.
And that'll copy once you release the mouse. That's it.
Okay.
If you're not able to get it, I'll be able to show you later on. Okay, so the part we're doing first up will be the side plate. So the key points that need to remain on this part is those two holes, A and B, they need to be in the same position. Okay. Apart from that, you can change the design of those sides, the hole pattern, whatever you like. Okay, you can even add on a bit of material, as you would have seen in one of the metal examples going around. So, what we're going to do with that one, start a configuration. I think again we touched on this one last week. So right click on the part at the top, add configuration, and name that one prototype. Now I'm going to delete all those. So then at this phase here, right, before we want to make our changes, what we're going to do is remove all of these holes. Now we can't just suppress this cut extrude because that's going to suppress that A and B hole as well. So instead we want to fill them in. One way of doing that is doing a sketch on that face, using convert entities and selecting inner loops. Select all inner loops and convert. Okay, it selects all the inner loops and then you can go extrude. Now we want to cancel out those two middle ones. Right, so you can select those two and delete that converted edge and then just do an extrude. All right, and that would fill in those holes. But the quicker way I looked at doing this last week is using the tool delete face. So that can be found under surfaces. So under the surfaces tab, I'll just turn a few of these off. It's a bit easy to see. Under the Surfaces tab, there's a button called Delete Face. Select options Delete and Patch, and then select the inside of these holes. And what it's going to do is remove that surface and then patch the hole that's left. And there's a hole on both sides. It patches them and fills them in.
Just where's the delete face button?
Surfaces,
Yeah.
Delete Face.
Chris.
Yep.
With these parts we're making, is it alright if we save the prototype part for like production as a completely separate thing, not as a configuration?
What I would like you to do is not save it as a copy. So the
Yep.
reason we do the configuration is so that it won't affect your drawings.
Yeah, yeah.
All right. So there's no need to save an extra file. You just press save here, and it'll still be fine
Yeah.
because all the changes we're doing are in a separate configuration.
Yeah, because I was doing it at home and I accidentally changed the whole thing without making a configuration first, so I renamed that as a separate file. So I
That's
have
okay.
the original and the other one. Is that right?
That'll be fine. Yeah. Yeah. No problem.
Just wanted to make sure so I don't have to
Yeah,
double
that's
that
cool.
now.
All right. So once you've done that to the shape, filled in the holes from here, so long as you don't touch those two holes, you can do whatever you want to the surface, to that face. Now, with this part, whatever we're cutting all the way through. All right. Whereas on the reinforcing plate, which is the skinnier one, we'll do for whoever's got that next. You'll have the option there to do some etching into the surface, which you would have noticed on the samples going around. So on this one here, it's really up to you. What you need to just consider though is when you're doing your shapes, what sort of material is going to be left. So it's all well and good for me to do some shapes like this and then extrude cut and say, oh, I want to cut out this shape and this shape. But when I do that and I get this option popping up here, bodies to keep, pressing OK, well, it's going to float in 3D here, but in reality that's just going to cut out the whole thing, isn't it? Okay, so you need to leave some joining material if you're going to cut away parts like that. All right, so I'm just going to spend a minute creating a pattern of some sort. You guys can work on the same, and then I'll get on to the next part. Just as a shortcut, if you hit the Enter key on the keyboard, that repeats the last command that you've done. So if you're doing a fillet or a sketch or an offset, it'll repeat the offset. Okay, and then you just select what you want to do next. Don't really know what I'm doing, just winging it. If you can't be bothered creating enclosed shapes, you know, basically outlining every single part that you want to cut away, you can sort of half create it, and then when you do your cut extrude, it'll ask you to select contours. So in this case now, all I have to do is just select the areas that I want to remove. Alright, so the shapes that I've cut will give me some options, and then I have to say, okay, I want to cut away these areas. Alright, now there are limitations to that, because where I'm cutting away this space, so when I select these two, what we've got here, and you guys may have encountered this so far with errors popping up, this would create what's called zero thickness geometry. Basically there's two edges that are solid that are touching each other, but they don't intersect. Alright, zero thickness. So if I try to press OK here, I don't think that will work. You see that error there. So that shape's not going to work like this. I have to do a few more changes before I can get that to work out. Here's another trick as well with your fillets. So let's say I've now got this shape and I want to fillet all of the sharp edges. I don't have to click every single one individually. When I click one fillet edge, I get this shortcut menu come up, okay, which shows me all the different options for that fillet. So this is connected to the start loop, which would be, you know, one of my preferred selections here. Connected to the starting face, between right feature and left feature part. So you've got all these different options that you can roll through. Now, I don't want to fillet like this because I don't want to fillet these top edges because they're going to be flat cut, right? The sort of fillet I would want to do is, you know, one like this or this, where I'm doing all the vertical type edges. All right, and that'll select them all for you automatically, and then you can play around with the dimensions. Now, when I go too big on the dimensions, they no longer work, so I have to scale it back. Might just stick with one. All right, and there's my part. So I just save that. Check my configurations work. Okay, default be prototype. To see what it looks like on the pulley, go back to my pulley assembly, the general assembly. Make sure I'm in the prototype configuration. And you can see then, when I select that part and go prototype, you can see how it looks. I've got some mate errors here that I need to fix up as well. They might be some I'll just actually suppress. There's ones with errors, and then just add a couple of new ones.
What was that thing you said about zero, like when zero thickness lines?
Zero thickness.
Yeah, something like,
Yep.
I don't know, I'm having trouble selecting the parts to extrude because they don't, like the areas to extrude because there's no intersections.
That's correct. So I'll just show you again in an example here. So I've already got one part here, one body. Now, if I do a sketch from the center out and then from the center out here, where they meet in the middle is 0 thickness. Okay, you can actually tell a bit by the lines. See how these lines here are thinner than these ones? When I try and go feature extrude, and I select these two areas, even though it will give me a preview, when I press OK, unable to create this feature because it would cause 0 thickness geometry. Now, there are times when I can get this to work. We haven't looked at this yet with our modeling, but if I uncheck merge result, it will create two separate bodies. All right, that will work, but they're separate. They're not joined together.
Yeah. They technically don't join. Yeah, I see what you're saying.
Yeah. So if I want them to join, if I want them to be one part, what I have to do here is create an overlap. Right? So I would have to draw something like that, where there's an overlap section. All right. Preferably then you would trim away that section so you can see where that join is. Okay, and then you get no problems whatsoever.
Is that the same reason why I just can't select a region? Like it's possibly
Yeah, perhaps.
allowing me to select the contour?
Perhaps, yep.
Yeah, okay.
Okay. All right, so the next part, anyone doing the reinforcing plate, similar process. Okay, start a configuration, and then very first thing we can do, that text, you can suppress that text. Okay, let's just assume that you want to change it to something else. So we're going to suppress that. Now with this part, again, we need to keep those holes, A to B. All right, they need to be in the same position, but the main shape of this body can change. So this is one where we can actually add some material back on. So you can do this in any number of ways. I'm going to try an ellipse. And I'm going to trim away these areas. So I'm going to add in material in that section. And then through the middle here, the difference with this part, and that you would have seen on the samples going around, the etched text in the surface. So on this part, we get an option to do either cutting through or both. So you can cut through in sections, you can also etch in sections. In SolidWorks in 3D, you can make it look one of three ways. You could, you could do the text like we did before with the manufacturing with an engrave that just goes 0.2 of a millimeter down, or you can cut all the way through, or you can cut a different thickness entirely. What you need to remember or start to think about, and we'll talk more about this later is when we export this file, all we're exporting is 2D geometry, okay, for the laser cutter, which means it doesn't read any depth whatsoever. All it's looking at is this top view of the part to see where the lines are. So it's in the next step, well, after we've exported, that we would tell it how deep to do each of those layers, okay, which layers are going to be engraving or etching into the surface, sorry, and which layers are going all the way through. For the process of the laser cutter, there's no depth cut, all right? So we can't say, oh, I want a laser cut 0.2 millimeter deep. The way the laser cutter works, and the text works on this example, okay, is the power, all right, the power on the laser is reduced. So instead of cutting all the way through the material, it only cuts a little bit of the way, all right? It won't remove a lot of material, okay? It won't create an area that's got like a depth to it. It's basically just cutting a line, but instead of cutting a line all the way through, it's only cutting it through, 20%. So whether we cut it all the way through in our SolidWorks here or not doesn't really make a difference. The only bit it makes a difference for is how it looks on our screen, but when we export it, it won't matter. All right, so again on this one, I'll leave it up to you whether you want to do some etching or some cuts or a combination of both. All right, and if you want to have it look a certain way, then make it look like that, but just remember when we export it, it's at that exporting stage that you need to designate, and we'll go through that again in a few minutes. So I'm just going to spend a minute creating a shape here. Again, you can do the same if this is your part. And then we'll continue on. just check again the configuration. Okay, so we've got prototype version there. Back into the general assembly. I can check that out again, prototype. I've got some made errors, but I can fix those up again later.
You fix those errors and then go back to the default configuration and then say back to the prototype configuration. Will those errors come back again? Or will they just...
In the default, it's totally fine.
Yeah.
Because I didn't delete any of the mates, I just suppressed them, the ones that were causing issues. So here I've gone, you know, there's a parallel one there.
Yeah.
Now I can just suppress that, and whatever is causing that problem, it's because I've changed this edge.
Yeah.
You know, here there's no straight edge anymore.
Yeah. So,
So-
remember that correction? If you were to go back to the default and then back to the prototype.
Sorry, on the this one here. Talk about this. Yeah. So they'll remove the error, but I'm dealing with it here instead, just by suppressing and adding different mates.
Yeah.
So the exporting of this part, it's in multiple parts. So first up, and I'm going to show the same step. So this is for the form bracket or the side and reinforcing plate, because what we're doing is we're creating a plain flat drawing to export a DXF file. So on our drawing view here, we've got a blank page. Model view, and then I'm going to start by selecting part 3, prototype configuration. Now see this view here, I don't want the side view, press front view and drop. And on the page I've got to make sure that it's a 1:1 scale, that's very important. Okay. We can do the same for part 5. And for the form bracket, it's a little bit different. I'll actually do that in a separate step, show you how that works. So what we're doing here, we're exporting these files to DXF format, and then we're going to open them up in AutoCAD to make some changes to the line work. If you need to go, just go. So any lines in these drawing views that go to our exported files, all right, when it goes to the laser cutter, they're going to be cut. So things like this crosshatch here on the circles, the center marks, we don't want those. We don't need them. So we can delete them here, and it's much easier to delete them here in SolidWorks than it is in AutoCAD. All right, you can just draw a box over all the center marks and remove them. Okay, so to export, File, Save As, change the file type to DXF or DWG. So DXF and DWG are pretty interchangeable. The way that I work, just so I know and can keep track of my files, when I export my files, I export them as DXF. When I've edited the files and they're ready to send to a manufacturer, I save them as DWG. It's just a simple system for myself, but other people have different methods. So I'm just going to name them prototype files. If this is it doesn't really matter because you'll have to resave them again. What you name them here, later on is where you need to change them. Under the options, you need to go to the options here, and this is very important, where it says spline export options, you need to check the box that says export all splines as polylines. This is to do with the way the line work is converted from splines and arcs in SolidWorks to the line type that you'll open up in another software. Right? So certain tool cutting software that's used with the laser cutters can be quite old, and it won't react well to splines, okay, the way that splines are set up. So it prefers lines as polylines. So to save us having to transfer it, change it all, or redraw it in AutoCAD, tick that box there and we should be fine. Press OK. and I'm just going to save that DXF file. 305, save. Alright, now that's very easy. So any flat part that you'd be exporting, you can use that method there, and that method allows you to put multiple files in one page and save them all and export them all at once. It's a little bit different when you have a part like the form bracket, which you've already converted to sheet metal. Alright, so we've already converted this to sheet metal. It's already got a flatten feature here. Instead of going through that process and laying out a flat drawing, I can just right click on the flat pattern feature in the feature tree and go export to DXF. Save as. Alright, that now opens up save as DXF, and it's going to name it flat pattern. Again, under options, once you've done it once on your system, that setting there, export all splines as polylines, should stay. Okay, you shouldn't have to check that again. I'm going to save it as that flat pattern DXF, press save, and then I get these property manager on the left of screen. I want to save the geometry, and because this part has bend lines, okay, I also want to include the bend lines. I don't need to include a bounding box. A bounding box is basically an outline showing you the maximum size of the part. I don't need to export that detail. Press OK. It's then going to open up a preview of what that flat pattern is going to look like. In this preview, if you had a lot of line work, you could actually select and remove some of the lines that you didn't want as well before you saved it. But typically, at this stage, press save. By doing it through this flat pattern, it's automatically going to be one-to-one. It's automatically going to flatten out for us, okay, and remove any extra lines that we didn't really need, like center marks. So here I've now got 2 DXF files. So what I'm going to show now, and what I will need you guys to do individually before you send the files to me, is this process in AutoCAD. So please open up, search and open up AutoCAD 2017, and we'll go through the process of transforming those files into something that we can actually send to the workshop. Okay, so AutoCAD. Has anyone used AutoCAD before? You enjoy it, Zach? What did you use it for?
Just for work.
Yeah? What sort of work stuff?
Consulting, but in air conditioning.
Oh yeah?
That's cool.
Yeah, that's cool. Any experience is good experience. When I did CAD in my first year of industrial design, we did 3 weeks on AutoCAD. We designed a Coimbra shit chair in 2D. And then we did SolidWorks after that, and I never touched it again in my course. And then, yeah, I hadn't really touched it for years, but when I got my first sort of job that involved working and exporting parts to a factory, all of a sudden I was using AutoCAD every day. Not as the main software, but as the software that would take your 3D files and designs that you've done in SolidWorks to something in 2D that we can send to our CNC router operator, or to send to our metal workshop, okay? Because they don't have SolidWorks, they need to receive files that they can just put in CNC machines, or their laser cutters, okay, or their router. So you need to set everything up. So learning some of the shortcuts and how the basics of AutoCAD work is very handy. And I learned a lot over my time this was at Active Display, and before that another place, just to use, how to set up files for this sort of purpose. So The interface is very similar to SolidWorks. You know, you've got all your menu options up the top. Down the bottom, there's a few different tabs. The one thing with AutoCAD is you can type in a lot of commands. So if you want to scale or rotate, you can just type it in, and then you follow the prompts, just select things and move them around. It works pretty well like that. So I've got these two files here. I've also got a nest file, which I will be putting everyone's files into before I send to the workshop. So I'm going to show you what that looks like. Let's cut nesting. Okay, so this is a file that I've set up previously where I've got some sample parts. Okay, and you see there's a few things set up with colors and layers. So just to explain, the way you would want to set up your file, okay, if you were doing your own project in future, is you would want first to have your material on hand. So you know how big your material is, what the thickness is, what the details are, etc. So you can draw the size of your material. So in this case, this grey outline is the size of the material. Okay. The yellow outline is then a nesting size. So I've come in, I think maybe 20 millimeters from the edge, on each edge, so I know, okay, this is the actual material I can use. And this varies process to process. So some machines, you don't need to allow anything, okay? You just need to allow whatever the laser cutter head or CNC router head can go, how far close to the edge it can go. Others you need to allow a lot more because you need to have really big clamps holding down the material. So this is sort of some of the information you need to get on hand before you go through this process. Next up, you set up the layers. Now, for you guys, you don't need to set up the layers, all right, for this project, but for future individual projects you're doing, you would want to do something like that. So, how to do that? On the screen here, in the middle at the top is Layer Properties. Click that button, and that will open up this pop-out window. I'll just make sure I'm getting all this on the video. So on this pop-up, okay, layer properties, you can see the layers that I've already added in. And you can see that there's a few points differentiating them. Okay, so to add a layer, you click this button here, think for new layer. And when you've created a new layer, you basically name the layer, whatever you want it to be. You can set a color for the layer. You can set a line type, whether it's construction or hidden or normal, continuous, and also a line weight if you needed different thicknesses. But typically just a color and a line type is fine. So the way I've set up my file here is with the different materials that we'll be using. So I've got one for the 2mm mild steel, which is the side plates, reinforcing plates, and then one material for the side plate, which is the acrylic, and giving them different colors. Any other notes or information like bend lines, or the laser bed size, the material nest size, or text, they're set up on different layers as well. So we're setting this up for a laser cutter, which is just cutting a straight line down. But if you're setting up something for a CNC router, which was cutting a certain depth into a material, and you can cut different depths, for each depth you would have a different layer. So if you had a 25mm block of material, you're cutting one depth to 5, 1 to 10, 1 to 20, you would have the 5, 10 and 20 on different layers. So when the toolpath or the software, the technician opens up your file, what they're preparing is to tell the machine which layer and how far it's cutting. So it'll take everything that's on the 20mm cut layer and it'll tell it, okay, this is the layer you're cutting down to 20mm. All right, that's the basic process that goes through. Okay. So what I'm going to do is I'm going to copy across those two files into this one, show you how to edit them, and then how to edit the layers. So I'm going to open up first the flat pattern file, and you'll see that you'll have this SOLIDWORKS educational text come up. Don't worry about that, you can just delete. And also going to open the prototype files here. So first up, just draw a box over them, and I can copy Control Tab and paste. I'll come back to that later. Just going to close these other tabs that I don't need. Right, and then same on this one. Control C, Control V. Alright, so you see this sample over here. This one I don't need to make any changes to, obviously, because everyone's going to have the same file. However, you still need to edit your file, set it up, and send it across to me so I can tick it off if you've got the form bracket part. What you'll notice, this file that I've already set up, when I select the outside profile, it's all joined as one line, one profile. So when the laser cutter is following line work, it's going to follow one line, okay? And then if it hits the end of the line here, it's going to go back along the other edge, all right? Or it's going to stop, or it's going to cause issues. So when you're cutting or setting up your files, all those lines need to be joined together. Now there's a difference between grouping them and joining them. As a group, it's you can move it around, but that doesn't mean that the toolpath software or the cutting software will actually read it in that way. Okay, so we need to join them properly. So the process to join them is a set of commands. So the first command is polyedit. Type in p-edit and press enter, and then it gives you options. So at the bottom of your screen you can see select polyline or multiple. I press M, enter. I then draw a box over the objects that I want to join. So it's all of these here, even though it's just the outside lines, I can select them all. Press enter. Convert lines, arcs and splines to polylines. Y for yes, enter. And then it'll give me all the options. And here I want to join. J, enter. Now fuzz distance, I don't know the technical meaning of that, but basically the lines that you can export from SOLIDWORKS, even though it looks like they may be joining at certain points, they may be a very tiny gap in between them. So sometimes you need to increase that fuzz distance to close that gap. For now this should be fine, I'll leave that as 0. Enter. And then at the bottom it says 7 segments added to polyline. So when I press escape and I now hover over that line, you can see that's converted that to one complete shape. Now the other thing that you need to sort of check and be aware of is that you don't have another set of lines under that first set, right? So to test that out, just select it, press M for move, and then you can click on that profile and just drag it away. You can see there's nothing left under there, so it's fine. Control Z to undo. That file is now ready for you to save and send on to me, okay, if that was your part. I'll show you a little bit more with these two parts here because I'll separate their layers as well. So these ones a little bit different because I've got some different shapes. You can see on this one here as well, when I select this part of the ellipse, that I've got these other command control points around here. Typically that's indicating a spline, which is something I don't want. Hopefully when we convert that to a polyline, that will remove any issues there. So the poly edit, I'm going to do again, and multiple. You can do it with multiple objects at once. So you don't have to do everyone individually, you can do a bunch at one time. Alright, so just again, copy of the
That's fine.
DXF import, save as.
Like when you're in the old one.
Yeah.
So you open your files, and I'm just going to Control C and Control V into this file. Now on this shape, these lines which are ellipses won't work, so I have to remove them. And same for these little edges down here. I'm going to replace those with lines.
And that's just the regular.
So line tool. And then what I did was an arc. I used start, end, and direction. So I selected the start point, the end point, and then the direction. So it's not exactly the same, but it's pretty close. Okay, so to join all these lines together, poly edit, so P edit, enter, then select polyline or multiple, M for multiple, enter, draw a box over the objects, enter, convert to polylines, Y for yes, enter, and then my option here I'm selecting J for join, enter, fuzz distance 0, enter, and it should join then everything together. So when you hover over it, you can see all those lines have been joined. Once that's done, now you don't have to do this, but I'll be doing it for everyone. I'm selecting, making all the line work by layer, set by layer, because I can then select individual segments and put them on the different layers that we've already set. So the side plate's acrylic. These hexagons up the middle are going to be text or etched. These shapes here and the ones in the middle are going to be holes, so they'll be on the through hole layer. And this last one will be mild steel. Right, and to finish off, I'll be nesting these, putting them all in a corner once I receive everyone's file, and then sending to the workshop. All right, so now we'll have a go at looking at the pulley wheel. So people doing the wheel: Aaron, Angie, Nick, and Kylo. All right. Our constraints for this one, what we'll start with is a blank. So what they're going to cut is a round block of aluminium. They're going to pre-cut the radius here and the side. All right. And so we'll change that. And it'll be the same diameter. Okay, what we get to customize is the pattern of the ribs. All right, and that detail on the inside. So we can go to our pulley wheel, open that up, and start by making a configuration. Now, first thing, we can go to this rib one here and press suppress. that's going to turn that off. I'm also going to suppress the fillet that's on this very outside edge. Okay, so I'm just basically at a blank type shape.
Just the outside edge, so
Just that outs, because there was a fillet, a small 1/2 mil fillet on these two outside edges, which I've turned off. And now I'm going to change some of these details here so that my part is going to accurately reflect the end result. So that top edge is going to be 2.5 mil thick, and the radius is going to be 10. So to do that, I'll go to my revolve, edit that sketch, and I can double click on that radius, change it to this configuration and change the number to 10. I'm also going to change this number 20 here, so that's a 1.5 mil thickness across the top, to 18. Everything else, oh, the only other thing that will change is the hole size here as well. That 13.2 can change to 10.5. And press OK. Alright, so now we've got our starting point for our customised
10
pulley wheel. The hole in the middle,
Yeah.
10.5, yep. Alright. So when we're doing this one, even though the first one we did using the rib tool, where we had a straight line and it did basically extrude into the body, if we want to have a bit of a different shape, we can use some different features rather than the rib. So you don't need to use a rib tool when you're doing this. To start off, I'm going to start a sketch on this outside face, and just as an example to show the sort of thing we can do, I'm going to draw a 3-point arc. And my basic idea here is to get a shape that I'm going to extrude down into the surface, all right, down into the body, and then pattern it. So I'm still going to retain a pattern, it's just I'm changing the shape of the pattern. Give it dimension. And so remember that offset tool we've used before, offset entities. I can select that line and I can offset that by a certain distance and do it bi-directional and cap the ends. You know, that's a potential option there. It may not go all the way in. I'm not going to worry too much about it actually. So I'm going to go and turn base geometry to construction as well. Press OK. Now this error is due to what? I don't know. It's a bit weird. It's very weird. Alright, just deleted one of those offset relations. Let's clean that out. I'm just going to add some tangent relations back so it's fully defined. And add a dimension back. The other thing I'm going to do is just select this edge here and convert entities and then trim away. So I've basically got a enclosed shape here. Now I'm going to extrude this down into the body, but I don't want this part coming out on the outside. Alright, so I change my end condition and I press up to next. And what that will mean is that extrude will only go up to the next body. Now the other thing I can change, because I don't want it starting on this top face, is I can change where it starts from. So where it says from sketch plane, you change that to offset and then put in a distance. So offset it by maybe 1 or 2 millimeters. So it'll actually start a bit lower, maybe 1, and then okay. Alright, so now I've got a curved rib rather than the original straight one. Now you don't have to do curves, you can do whatever you want. I've even had instances, I think maybe even one of the wheels going around had just a square shaped pattern cut into it. You can do whatever you want inside that area. The one thing that we need to consider with this object is this is a bit different to the laser cutting. Alright, this is a 3D object that's going to be cut using a drill bit. Okay, using a tool. So, to explain about that a little bit more, I'm going to see if I can find a video on that that will explain a little bit more about the process. Should have done this earlier, but the internet working? Not working. Okay, let's have a look at this. Alright, so what you can see in this video, this is a very similar process to the machine that we'll be using for the Haas mill. Now the difference is this has a moving drill bit head, okay, that moves along the object. Alright, ours will move as well, but it's going to be in a much more limited space. So the Haas, which cuts metal, aluminium blocks, can only cut a certain size. One of the things you'll notice though, having a look at this and the detail, there's no internal corners that are square. So even if you look at these corners here of just the outside border, you can see in this area here, there's a little bit of a curved area, okay? Now it's pretty small, but that's to do with that drill bit. So you imagine that drill bit's round, coming down and cutting into that material. So wherever it moves, any internal corner is not going to be a square corner, it's going to have a rounded fillet. So when we're designing our wheel here, if you can imagine that drill bit coming down into this area, okay, it's not going to be able to cut that square edge. So to replicate that, we need to put fillets into this model. Now what you would do if you were designing your own part and prototyping it, you would find out from the workshop what size drill bits they would cut this material with. And let's say it's a 6mm drill bit, then that means you've got a 3mm radius as your minimum. So I think the Haas, and you might be able to find this information online, is either a 5 or a 6mm drill bit. So I might just go, let's say a 2.5mm radius, and I'm going to select those edges. Press OK. Right, so that's given me a bit of a better indication of what that would look like after it's been cut. Now you can change the order of the fillets, you don't have to necessarily do it in that way. You might have a small 1mm fillet across the top edge. You can have a smaller fillet on that top edge because that's an external corner. The drill bit will come up and around over the top. Alright, there's no limit there as far as the minimum goes. It's only those other edges which need to keep that minimum 2.5. Once I've done that minimum, I can then create my circular pattern. So I can select that axis, features and faces to pattern, select the extrude and the fillets, the spacing number, and put them in, put those details in. Now when you're doing that pattern, you have to be careful that your fillets aren't overlapping. So when I get something like this here, that may prevent me from completing that pattern. We'll see. That's worked okay. It's a little bit messy, but that's okay. Alright. So you can try something like that out as well. What I'd also want you to do is mirror that to the other side. So again, right plane, mirror, select the pattern and geometry pattern and press OK. Now what I might have to do here is select the original, sorry, this is where we've got into some limitations. So this is the limitation of the extrude up to next feature. Alright, so instead of using the rib feature, we use that boss extrude going up to the next body. We're not able to mirror that because it's trying to extrude up to that same body, potentially. So if we want to recreate that across the other side, we may have to actually get a bit more creative. What I'm going to do here is an insert feature split. I'm actually going to cut it in half, remove half of that, and mirror the entire body across, and then merge it back together. Okay? So it's just a different way of doing the mirror. If we're prevented from doing it one way, there's usually another option there. Once you've done with that pattern on the side, because this part's going to be cut 3D, all you have to do is export a 3D file and send it to me. You don't have to do any other preparation, okay, changing of line weights or file types. All I'd say is just check your default configuration is still fine with your file, and then go back to the prototype, save it, and when you're ready, the file type you need to export will be an STL file.
Could you very quickly, the splitting in half and mirroring thing?
Yeah, certainly.
Sorry,
No, that's okay. So we haven't used the split tool much yet. I use it a lot. I normally have it up here on my toolbar. But to do it, you go Insert, Feature, Split. And you can select anything as a trim tool, including planes. So I select the right plane, and then I press Cut Part. That cuts it in half. I can then select which half I want to remove. Now to remove it, I've got to make sure that the box Consume Cut Bodies is ticked. I then press OK, and it removes that half. Then to mirror, we've done mirror before. I select that right plane or that middle face. And now instead of mirroring any features, I'm going to mirror the whole body. So I select this side as a whole solid body. Make sure Merge Solids is ticked. Press OK. And that completes the feature. When you're saving and exporting your file, go Save As. Rename your file so we know whose it is. So to name your file, you'll have to have my name first. So you'll be naming it Chris, group whatever group number you're in. If you don't remember, just yell out, I'll tell you. Group 0. And 1 to 4. Actually, sorry. Let's do this a bit better. Give it your name. Your name. And then Monday. Group 1, 2, 3 or 4, whatever one you're in. Alright. Change the file type to STL. You don't have to do anything in options here. Your name, Monday, group 0, dash wheel.
Group numbers.
Alright, doing the wheel. Aaron's group 1, Angie group 2, Nick group 3, Kylo group 4. So your name, Monday, group 1, 2, 3 or 4, wheel.stl and save. So when you save STL files or a couple other different 3D mesh types, you'll see this preview come up as well. It's just giving you some information about your file and how it's split up, okay, into the mesh or convert to the mesh. Just say yes, that's fine, and that'll save. That STL file, which you can see here, it's usually a bit of a bigger size, okay, mine's 3.5 meg. But that's the file you can then email to me to check off. Right. So far I've got one file. Thanks, Zach. Everyone else, I need your files, please, for your side plates and reinforcing plates. All right, we'll do the last one now. So the pivot pin. So, Henry, Daniel, Nick, and Sam. Let's just put this configuration in here so we can have a look as well.
Hey Chris, you saying something before about not wanting splines?
Yeah, when you're saving your DXF, press Options, and then press the box that says Save All Splines as Polylines.
Okay, cool. So we can use splines as a tool.
You can,
When designing.
but when you're editing it in AutoCAD, you need to make sure
It's saved.
that you're able to get it as one complete profile. If you can't, then you need to edit or manually remove those lines to create new ones so you can join them up.
Just one question about the blue wheel.
Yep.
We had to make the internal radiuses 2.5 for the drill bit. There's a couple of internal radiuses that from the fillets on the inside edge of the circle that is still not 2.5.
Where?
Like outside, on the outside circle.
Outside circle.
It's hard to, I can't really point. I just
Just point
pointed.
it.
Like these ones and these ones.
These little ones?
Yeah.
Yeah, good point. Okay. So these little ones here, firstly, these ones here,
They're external.
they're external, no problem. These ones here are a potential issue. Let's do a section view. So here is the problem, okay? When we're coming down the corner, that's a nice large radius, okay, 2.5, that's fine. This shape here, this is essentially the bottom of the drill bit. So it depends on the shape of the drill bit, what sort of shape we can get on this bottom edge. If the drill bit's flat, then if the drill bit is flat, when it comes down, it's going to be moving along this edge and then it'll have to raise up and come up here. I think either way it might be fine. Because the other type of drill bits are like a ball pointed end, like a round semicircle type end drill bit as well, which can cut away. I can't remember specifically what the Haas machine has for us to use. If you're doing your own prototyping project, it's a consideration and something you would discuss through with the technicians. For this project, it'll be fine to keep that bottom radius in. All right? Good question. All right, pivot pins. So the pivot pin's a little bit different because it is the one object that is not going directly from a CAD file into the metal lathe to be then cut. And this is the problem we used to have with the old DI wire bender. So even though we could design this wire hook thing, we could do it in 3D, there was no way of exporting the SolidWorks file to something and then importing it into that software, okay, just because of the limitations on the software. It's the same with the metal lathe. Although we can put in numerical inputs, we can't put in a digital file. So the changes that we're making to this one, all right, there's a lot of detail on this page, which you don't have to concern yourself with. The main change is that we're losing that lofted shape. So that lofted shape where it was a circle to an ellipse to another ellipse, that's gone, and it's now going to be a complete revolve. All right, and it's a complete revolve because when we're cutting it on the lathe, it's spinning around in a circle and cutting the same shape all the way across that pivot pin. So the maximum diameter is going to remain at 20. So that's that main flat shape on the outside. The height, we're going to limit it to 38mm total. We'll come back to that. The shape on the bottom of the pivot pin, that's going to change as well. So we're going to lose that arc and that pressed up shape. These holes, they're going to be pre-cut and they're going to be cut at a certain position as well. So those holes need to be set. So the bit that is variable with that pivot pin is the shape of the curves on the outside. So basically from this top point around to this bottom edge is the part that you get to customize. The workshop has sent some instructions about how the drawing needs to be set up for the CNC lathe. Every straight line must have a start and end point relative to the X diameter and Z reference lines. Curves need to be broken down and use arcs. Arcs can be done with a start and end point, a radius and a center point. Center point must be dimensioned. Right? This is just a stock sample here. You know, the sort of basic normal stuff they cut, which is flat. And this is how it would look on the drawing. Alright, so we're highlighting or going to be indicating where there's an arc here. We've got the end point of the arc, the middle point, and then the radius in between. Alright, so we're going to create our pin and then we're going to create a drawing. And that drawing we will send to the workshop for them to cut the parts. They'll input the values from the drawing into the lathe to then match what you've designed. So, to start off, we're going to create a configuration and just get it back to a point where we can change it to a full revolved type part. So, open up your file, create a configuration, and I'm going to start off by suppressing the loft, and that'll suppress all of those features after that loft as well. Now at the bottom, we're going to remove these areas here. Like we have previously with on the side plate where we removed the holes, we can use the delete face tool. So I'm going to select those two faces, press delete and patch and OK. It doesn't want to do it. Alright, we'll do it a different way. We're not going to edit this sketch because anything we change in the sketch would affect the original. So instead, let's cut it off. So I've started a sketch on the front plane. I'm going to select this edge and convert. I'm then going to go features, extruded cut. Now, even though I've just got a line there, the cut is going to go to the direction of this arrow. And I'm going to go through all both. And press OK. And it basically cuts off that bottom half. So then all we've got left is this starting point. So on the bottom, I want to get it looking like this here. So it's going to have a height of 8 millimeters. At the moment, you can see that it's 6. So this is one part that we can change in this original sketch. So I'm going to edit the sketch, click on that dimension there of 6, link it to this configuration, change that to 8. Press OK. Later on, we'll come back and cut the hole. But what I'm going to do now is actually set up that sketch for my 2 holes. So we've got a 4.2 millimeter hole here, and we've got a large hole at the top which is 10 millimeters. Select the center points of those and the origin to make them all vertical. And then we're going to add some dimensions. So the hole at the top is 17 millimeters from that top edge. And the hole at the bottom is 1.9 mil from that bottom edge. Now that 1.9 is to the top edge of the circle. So when I select the circle, I hold shift to use that edge of the circle. Press OK. This sketch is going to help us later to know where to sort of make our curves. All right. So now we're looking at a maximum height of 38. So now we're going to set up the sketches to doing our revolve. All right, so we can control the curves and then be able to create the drawing later on. So we're going to do another sketch on the front plane and start with a construction line that goes up the middle. And I'm going to set the top of that line to 38 millimeters from the very bottom edge. All right, so that sets our overall height.
Is this a separate sketch during the circles?
Yeah, separate sketch. Okay. So this drawing here, even though there's a lot of lines and information, breaks down how we can sort of draw our curves. So what we're drawing, we're going to have basically 2 curves. To make it a bit easier, I might rotate this page. Okay. So we've got one that comes out from the top and then one that joins up to the bottom. They don't have to be the same size or radius. So to start that off, let's do it with the 3-point arc. Draw one and then the other. Now, some keys with this. First up, the center point of the top arc must be connected to the center line. Alright, that will mean that at the top, it's going to be tangent and smooth. We can make it bigger or smaller, okay, but the center point must be on that center line. The second bit is that the two lines, these two arcs, they must be tangent where they join. So I'm going to select those two arcs and select tangent to make sure they're smooth. Once we've got that, we've now got our adjustability sort of locked in. So from here we can pretty much set up the shape that we want our pivot pin to be cut. The previous sketch where those holes are, particularly the large one at the top, says that we can't make this too skinny, okay, because it's going to cut that hole all the way through later on. That's going to be cut on a drill with a drill press. So try and design your shape of your pivot pin, you know, to suit that top shape. Now the other one we don't want to do is at the bottom, we don't want this shape cutting in, all right? That undercut won't be possible to be cut on the lathe. All right, so just move it until you find the sort of shape that you want to create. You know, if you want it to be perfectly centered around that top point, you can do that, that's fine. You can drop it on the center point of that circle. That just limits you even further with the shape that you can create. All right, I'm going to leave mine there. So I'm just going to get it sort of close, and then what I'm going to do is dimension that point, okay, the point between those two arcs. So I select that point and the center line, and I'm going to put it in dimension, and you can round it off if you want something that's just a neat number. All right, and now that's created the arc that we're going to use for our revolve. To use the revolve, we've just got to close the shape. So take that construction line in the middle, uncheck for construction, so it's now solid. Join up the shape at the bottom and go features revolve. Select the line in the middle, press OK, and that creates our revolve shape. We can then select the previous sketch we've done with the holes and go extrude cut through all both, and OK, and that shows us the end result of our pivot pin. I can check that out in my sub-assembly now. Make sure I'm in the right configuration first. And I can also save that, and that will update in the general assembly. So once you've done that, the last requirement for this part is to create that drawing. So I need you to go make drawing from part, select drawing, just make it A4, but just make it custom sheet size. So it's just a blank A4 page.
Where's make drawing from part?
File,
Yeah. Ah, cool. Yeah.
make drawing from part, or just file new drawing, either way. And what you're doing is you'll be recreating this drawing view with the same layout of dimensions. Your numbers will be different, but where those dimensions are going, that's what you need to include on the drawing. So go model view, and it doesn't need to be 1:1. You can actually make this one a bit larger, so it's a bit easier to read on the page. 5:1. I would suggest a see at the bottom here, this center mark, the circle, you can select that center mark and select the top point and drag it all the way up. Basically acts as a center line. The other thing we want to do is have a line at the top to do all these other dimensions from. So I'm just going to draw or sketch another line here, construction line. All right, and now I'm going to add the dimensions. So basically, we've got to dimension the start and the end point and the center point of each of those two arcs. So to find the center point, you can dimension a radius that'll indicate it to you. It's not going to actually create the center point. What I need to do is create a point on the center point of that circle. So on my sketch tools, there's the point tool. I can press here. I can highlight that arc, and when I do, it brings up the center point, which you can see there. All I have to do is get that somehow to snap and stay fixed to that point. If I can't get it to drop and be permanently fixed to that point, dropping it there, you can see when it's adding a white relation, the white relation means it's not actually going to add anything. I can try and do it manually, so select the point, hold control, select that arc, make it concentric, and now that point is locked to the center point. Alright, so from there, the other center point's easy, that's already there. I'm going to add those dimensions, so what we can see here, I've got basically height to the midpoint that joins them, the overall, and the widths across there. So I'm just going to add those dimensions and come back to it. Try and work out if I've done the right thing in a second. Now when you're doing these drawings or these dimensions to points and edges that are already, like these lines that are drawing on, you'll get that warning saying, you know, adding this dimension will make a sketch overdefined. Tick the box that says make it driven. Alright, it'll turn that dimension grey, but that's fine. Alright? That's just going, it's just saying that, you know, this line is already fully defined, so your dimension's not going to do anything, but that's fine for us. We just want to know where those points are. So I've got center point of that circle, the point where they join, the center point of that circle, and then the 25 mil. So they're my 4 across the side. And then going horizontally, I want that first point there, halfway. I want that end point, which is 20. And the center point of that circle. consistent, I'll just do point there. So I've got 3 measurements. So I've got 3 measurements across the top, 4 across the side, and then I need to dimension the diameter or the radius of each of those arcs. So I've got the one at the top here, which is radius of 8, and the one at the bottom here, which is a radius of 11 point something. Now, as much as you can, make your drawing clear to read. Now, this is one where you can change the properties of your page and your annotations or dimensions, sorry. You can, if you want to refine your dimensions, just make them all to 0.1, that's probably enough. And then your leaders, which are these, if you want them all to be sitting nice and horizontal, you can just go through each of those options. Right, to get all those numbers sitting nice and easy to read. Last step, add your details to the page. So with that annotation note, what I'd like you to type in, the same way that we named the wheel. Alright, so it'll be your name, Monday, group, and then pivot pin. Make the text nice and large so it's easy to read. Save that drawing just so you've got a copy of it. PO1 prototype. And then print the drawing. So this is something that we'll cover again in a couple of weeks or next class. This for our actual tech drawing set. But what I need from you if you're doing this part is a PDF file. So from this point here, once you've done all the dimensions and put your name on, go File, Print. Instead of printing it on an RMIT printer, select Adobe PDF. Press Page Setup. Make sure it's A4, scale 100%. Press Preview, it'll show you. Also, you can check orientation there, portrait. All right, that looks pretty good. All the dimensions we need. Press Print and OK. And it'll ask you to save the file, which is correct. Save it as per the same name that you put on the file. So your name, etc., etc. Pivot pin. Save. There's my PDF file, and that's the file you can then email on to me.